welcome to Pre-Calculus 11. Today we're going to be looking at Complex Algebra 1, that booklet. So let me just get it out here for you. This guy right here, we'll be doing it over two separate lessons. And so the first lesson we're going to talk a little bit about absolute value up here. So if you recall, the graph of absolute value was that V graph. We'll just review a little bit of what absolute value means. And then we'll look at square root graphs. And in the process, we also have to review quadratic equations. That's the ones where you have to factor. We have the quadratic equation. I'm not going to give you stuff to work out with the quadratic equation, but we do need to kind of revisit that idea. And then today, this is your kind of first introduction to a new idea in mathematics for you. We maybe talked about it once before, and it has something to do with extraneous values. And you're getting to a point now in your math life where you're going to have such advanced skills with algebra that you're running into problems with the program of algebra. We have things like square roots and absolute values and quadratic equations. Way back when algebra was first invented, they didn't have these things able to connect to each other. Now we do, and we're seeing some glitches, some bugs in the programming, if you think of it that way. So we have to watch out for those. It's a new detail, a new wrinkle in your math world. And that's something called an extraneous value. They're basically bad answers. We'll go through some examples when we get there. So let's get started on absolute value up here and how to sort out those particular equations. Alright, so if you remember absolute value, it makes everything positive. Whatever's inside those flat brackets becomes positive. So here we have the absolute value of 6. It's already positive, changes to positive, well, it doesn't change, it just stays positive. In the middle one, we have the absolute value of negative 6. So that becomes positive 6. That's what the function tells us to do. And then over here, I've kind of got a compound idea. It's negative 2 times the absolute value of 3. So this just illustrates that it's only the absolute value part that winds up changing. The negative 2 stays as negative 2. Then the absolute value of negative 3 goes to positive 3. And then just negative 2 times 3 is negative 6. So you can have negative answers involved. And we looked at this kind of already last unit when we did the graphing. So we're just exploring what the algebra behind this looks like. And eventually what I want to do with you is I want to show you how to connect the algebra and the graphing that you do. It's one of the overarching themes of the entire course, is to be able to connect those two details with you. And that allows you to go to work between different parameters, different dimensions of math space. I don't know, that sounds kind of science fiction-y, but it allows you to work in different layers of that and find the layer that is most efficient for your problems. Because in some cases, one way is better than the other, and it's quite obviously and clear. So, we've learned the graph of absolute value. Now let's learn the algebra behind it, and then at the end of the unit, let's see how they connect together to get optimal efficiency and precision out of the work that we do. Save you time, right? Save you time having to look at me. Okay, so let's get started on some algebra. Okay, so if we look here at one of the most basic examples, I'm asking the absolute value of what number is equal to 6. Well, we have absolute value of 6 is equal to 6, and we have the absolute value of negative 6 is equal to 6. So we really have two answers, right? One for the positive and one for the negative value. So in pretty much all your examples, you're going to get at least two separate answers for each question that you do. Now this is very simple. Let's, crank it up a little bit. Okay, so the absolute value of 2x is equal to 6. So, okay, well, the number has to be able to equal 6 when it's finally done. So, and this is the problem with doing algebra like that. If you try to guess ahead, you're going to run into problems. So instead of trying to guess ahead, let's look at some of the processes so you don't have to, exert extra energy trying to guess it and then figure out how to write some algebra to make it look like you know your algebra. Okay, so let's play this out. So my answers are x is equal to 3 and x is equal to negative 3. And well, 2 times 3 is 6, and then 2 times negative 3 is negative 6, but the absolute value part makes it positive. So I have two answers. Okay, so there's my two separate answers again. Let's see if we can see some other patterns in some other questions. Okay, so here's something again, the next one down below. I have the absolute value of x plus 1 is equal to 6. So I got to figure out how to make it equal to 6 and how to make it equal to negative 6. Right, because then the absolute values will make it positive and then I'm good. So, okay, so I have 5 plus 1 will work, and negative 7 plus 1 gets you negative 6, and then the absolute value, right, kicks in and makes it positive 6. So, okay, two answers again. Alright, so in the next one down, I have the absolute value of x, and then a plus 1 equals 6. So really, I have to make that equal to 5, right, because then the 5 plus 1 will get it 6. So I could have positive 5, or I could have negative 5. Again, two answers, right? Okay, so let's see if we can put together a strategy. Okay, so here's kind of like the level of difficulty I would expect you to be able to handle by the end of the unit. And so I have 3 times the absolute value of 2x minus 1 plus 4 this way. Sorry, I have to work in mirror image when I'm doing this stuff, so that's why my hands go in different places. And then equals 25. So, alright, let's set up the t-chart, right? Theory, practice. Alright, step 1, isolate the absolute value brackets. That means I have to move that plus 4 and that times by 3 to be able to isolate the absolute value bracket. Okay, let's see what I get. Okay, so I had to subtract 4, right, to both sides. So that gave me 21 there. And then I have to divide off the 3 to both sides. So 21 divided by 3 is, of course, 7. So I have an isolated absolute value bracket. Now I got to deal with this stuff on the inside. So your first job is get to the bracket, and then second job is deal with the inside. Here's how that looks. Okay, so I want to split the equation into two parts, just like so we get our two answers, because every time now you're going to get two separate answers. One for the positive 7, so if I can figure out what makes it equal to positive 7, I got an answer. And if I figure out what makes it equal to negative 7, I've got an answer, which, you know, is really, really helpful. So, okay, let's see what those equations look like. So if I want to get my answer for x, I have to be able to figure out what makes it equal to positive 7, right? Because if I can figure out what makes that bracket positive 7, then I've got an answer. And then if I can figure out what makes this bracket equal to negative 7, right, when I plug in negative 7 and I absolute value it, right, when I do that job, it becomes positive 7 too. So that's why we need two separate equations. One for the positive and one for the negative. Okay, so I have to solve both equations. Alright, so I get 4 and negative 3. So, okay, let's have a look at one that doesn't quite work out how we planned. Let's look at an extraneous value answer. This will be our next question. Okay, so here we're kind of ratcheting it up another level, a little bit more abstract than the other one. So okay, I have absolute value of x plus 15 is equal to 2x. And up to now, we've only been dealing with something equals a number. But it can also equal another expression. And it's hard to visualize this right now because we don't have the tools of analytic geometry, which we will get at unit end. So this makes a lot more sense when you can solve it by a graph, actually. But for now, let's look at the algebra behind solving this guy. And it's the same as all the other ones. We have to split the equation into two parts, one for the positive and one for the negative. So what does that look like? Okay, so I just make x plus 15 equals positive 2x, and I make x plus 15 is equal to negative 2x. So I'm putting a positive and negative on the function, the function that it equals, the 2x part. Yeah, it's totally legit to do. When we see analytic geometry, you'll see why it works that way. But it's a nice little trick. It allows us to solve this question without having to try to guess what the answer needs to be. Now we just have two simple algebra questions, and bada bing, bada boom, you solve them. Okay, when we solve them, just, regular simple algebra, when we solve them, we get these two answers. And you're like, yeah, I got my two answers, next question. But one of these answers is not correct. Yep, one of them is not correct because, like I had mentioned before, what we have is we have an old operating system of algebra operating with a newer system with absolute values, and embedded in that connection is a small problem that you have to be aware of. So you have to check your answers. So let's see what happens when we check. Okay, so on the left-hand side, when we plug things in, it works itself out quite easy, right? I got x equals 15. I plug it back in. You can see the work down there. I get absolute value of 30 is equal to 30. So, yep, that's good, right? That's fine. That answer works. But over here, when I plug in -5, right, this is what I get. And I get the absolute value of 10 is equal to -10. And at first glance, if you're not really paying too much attention, you might say, oh yeah, that's right. But that's not right. Right? Absolute value of 10 is positive 10, and this gives us -10. It gives us a wrong answer. And you might be saying, well, how can algebra give you like a wrong answer? And it has to do with that connection between the two systems. There is a bug in there, and this is how you see the bug play out to start. When we do this analytic geometry stuff, you'll see why you have that. It just gives you a better visual aid in order to be able to solve these questions. But for right now, we don't have that, so we have to check to see our work. And you might be thinking, oh my gosh, I've got to check all my work now. And the answer is no, you don't. But you should know when you need to check. Because sometimes you don't need to, and other times you do. And there are some very simple things that you can look for that make it quick and easy. So it's not as bad as it sounds. Okay, so let's go on to square roots from here on out, and I'll show you how to manage some of those. We got to remember how to do quadratic equations, and yeah, so that's enough of absolute value for the moment. Okay, so here we have square roots, and we'll just start off basic, and then we'll add a little more complexity each step along the way. So over here at the start, right, I've got the square root of x is equal to 6. So, alright, you guys probably guessed the answer is 36, of course. So, in order to do this with some formality, the opposite, or the way to cancel out a square root, is to square both sides. Now, there's a whole bunch of reasons for that. Mostly it's intuitive. And next lesson, I'm hoping I'll remember to show you the theoretical reason why that plays out if we think about them as exponents. But for right now, we square this side, and we square that side, and that gives you x, because they cancel out, the square and the square root, and x squared is equal to 36. Pretty easy, straightforward. A lot of you guessed the answer before we even started the algebra. But going on to question number 2, okay, I got the square root, and then I got an x plus 1, and then I got this equals 6. So you might be able to guess it, right? That should be 25, I think, because 25 square root gets you 5, and then 5 plus 1 is 6. So yeah, 25 is right. But if you don't do the squaring and the subtracting in the proper order, it's going to mess it all up. And so let's make sure we do it right. Okay, so in order for me to get that, I'm going to have to try to figure out what makes it equal to 5, right? I have to minus 1 to both sides. And I'm left with the square root of x is equal to 5. And now I can square both sides. And that gets me x, and that gets me 25. Alright, let's have a look at this next one. So I have x plus 2 square rooted is equal to 6. So do I deal with the plus 2 or do I deal with the square root? And so, as always with algebra, if you use the rule of thumb that I have, where you try to solve for the variable that's on the try to eliminate the part that's furthest away from the variable. Then that's how you should do it. And generally, this is what we would do. We would cancel out the square root first, so square both sides. So I'm left with x plus 2 is equal to 36, and then I'm minus 2, and I get x is equal to 34. Okay, so you have to cancel the parts on the outside of the equation and then cancel out the parts on the inside of the equation after, like, inside of the square root. So let's do question number 4 together. Okay, and then a minus 1 to both sides. That makes that 5. Square both sides. So x plus 2 is equal to 25, minus 2, and I get x is equal to 23. So again, we work to isolate the the square root part, and then we work to get rid of that square root bracket, which is the square both sides part of it. So let's have a look at a level of difficulty you'll be expected to see and do in your booklet. Okay, so here's one that requires a few steps. 3 times the square root of 2x minus 1 plus 2 equals 11. And it's very similar to how we dealt with the absolute value question. We first have to isolate the square root bracket. So let's do that. Alright, so I had to add minus 2 to both sides, making the 11 a 9, and then I got to get rid of the times by 3 by dividing by 3. So I wind up getting the square root of 2x minus 1 equals 3. I've isolated the square root bracket. Now let's finish it off. Okay, so I square both sides, gets rid of the square root bracket, and then 3 squared is 9. So 2x minus 1 equals 9. Okay, regular grade 9 algebra will get you from there to the end, and so I add 1 to both sides. Mr. Gerard can't even do grade 9 algebra. Yeah, I didn't make a mistake there at all. No. Okay, so to add 1 to 9 makes 10. 10 divided by 2 equals 5. So there's your answer. Okay, x is equal to 5. Now I want to look at one that has these extraneous values. We're going to get another bad answer. And this one is a little bit easier to understand and see how it plays out, because I'll go through a bit of a backstory before we start the question. Okay, so this might be a little bit more intuitive other than the last question, because you can kind of understand where this comes from. And we have seen this notation before in the quadratic equations unit. So the one in like November, December. So extraneous values backstory. If I have x squared equals 9, I have 2 answers. Most people think 3, but a lot of people forget negative 3 also works. Right? Negative 3 squared is negative 3 times negative 3, the negatives cancel, and so I get 2 answers. But when you do the math for this, it only shows 1. Right? That's what you would get if you plugged it into your calculator, but we know that the other one exists, right? So there's, again, a hidden problem with the algebra that starts here, where we saw it way back, and our notation that we used was it was also equals negative 3. Right? We write it like that. And although neither of these are extraneous values or anything like that, it sets the stage for your knowledge that algebra is not perfect. And so let's have another little quick example. Okay, so here in the next example I have the square root of x is equal to negative 3. And okay, so let's just do the algebra and see what we get, right? To cancel out a square root, we got to square both sides. Okay, so we square that side, and we square that side, and I get x, and minus 3 squared is 9, right? Because the negatives cancel. But 9 is not the answer to the question. If you take the square root of 9, right? If you take the square root of 9 on your calculator, it gives you positive 3. So this answer is not correct, technically, right? There's no value of x that can give you a negative value when you square root it. So automatically this should indicate to you that there's not going to be an answer. So this 9 is an extraneous value. It's a bad answer. It's a glitch. It's a bug in the work that we've done so far. Right? Because square root of 9 is 3. Well, you're like, well, negative 9. Type it in your calculator. Square root of negative 9 doesn't exist. Remember imaginary numbers? That would be 3i. So that doesn't work either. So we have no solution, right? This is an extraneous value. So if you were to show me that, you'd have to cross it out and say it's an extraneous value. EXTR value. VALUE. Extraneous value. But you know that it's not correct. So you could either, if that was the only answer you got, you could just cross it out, erase it or whatever, and just say no solution. Or no real solution, if you want, I guess, to be totally correct. No real solution. There's an imaginary number solution, right? But there's no real solution. So, okay, this also extends to the idea of the work that we're doing in this booklet. So let me kind of go through some of that. Okay, so here's the question. The square root of what number plus 6 equals that same number? Okay, ready? Here we go. Okay, so I square both sides, right? That's how you got to get rid of the square root symbol. So I square both sides. And so I get x plus 6 equals x squared. And that, if you recall, is a quadratic equation. We have an x squared over here, and we have an x over there. Those are unlike terms. We can't gather them. Then remember, we have to do the factoring business. So let's go ahead and finish solving that. Right, I write it as a trinomial, right? Usual factoring setup. And so I got to figure out what multiplies to negative 6 and subtracts to negative 1. Okay, so see if you can remember that. Here it is. We practice that in grade 9, we practice it in grade 10, grade 11, grade 12. We do so much factoring. And it's actually one of the things that we have as an advantage over many of the students that come from Europe, is that the students from Europe don't factor well or much at all. They don't really have it as a major part of their curriculum. I've seen a bunch. They're given the formulas for it a lot earlier, and those formulas, although mechanical, don't really foster good creativity and core knowledge. So I think it's a bonus for us here in Canada that we learn this early. So anyways, there's the factoring, bada bing, bada boom, right? We have to figure out what makes each of those brackets equal to 0. So the answers aren't negative 3 and 2, right? It's whatever makes those brackets equal to 0. So let's finish it off. Okay, so x is equal to 3 and x is equal to minus 2. Hooray, right? We've got the answers. No, we have a bad answer in there, and we have to look to see to find it. So you got to go through the check. Oh, check. I know, check. Right? We have to do it. Next video, I'll show you when you can skip it. Right? Because there's certain signals in the question that allow you to know whether there's going to be one for sure or not. And when we, like I said, when we do analytic geometry, it'll make it even more clear when you need to do it or not. But for right now, we don't know, so we got to check. Okay, so when you're checking, right down here, when you're checking, make sure that you check back in the original question. Now, there are some places along the line where you can kind of skip ahead to in some cases, but by and large, you'll never go wrong if you check in the original question. So when I check over here for the first one, right, x is equal to 3, right, I check x equals 3, I plug it into the equation. I get the square root of 3 plus 6 equals 3, square root of 9 is equal to 3. That's fine. So that's a good answer. But when I check the next one, this guy over here, right, here's the work for that. I get the square root of 4 is equal to negative 2, and that's not correct. Square root of 4 is positive 2. So that's a bad answer. That's an extraneous value. And on the test, you list the ones that are right, and for the extraneous values, you either erase them because they're not actually answers, or you just put a line through them like that and let me know that you know that that's not a good answer. Because that's something I look for, right? Are you aware of these subtle little differences? It's the difference between an A and a B, or a low A and a high A, right? It's a difference in knowledge, and it's one of the little things that I look for to separate different levels of student achievement. Okay, okay. So this last video supplements and complements this booklet, Complex Algebra 1. And you have enough information to be able to do, let's have a look here. Page 1 for sure, page 2 for sure, yep, page 3 even. I mean, it looks like you can go quite far in this with what you've got. So, next class, what I'll do, or next video, I'll help you with some of the harder questions in this booklet, and we'll talk a little bit more about some of the finer points of finding extraneous values, when you need to check, when you don't, so it can help speed up the work that you do. Right, so that'll be next video, coming shortly.